Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala Muhammad Rasulullahi Kareem. This problem is related to maxima and minima of this problem also related to partial differentiation of in differential calculus. Problem is, a company manufactures two types of athletic shoes, jogging shoes and cross-trainers. The total revenue, question started from here, main question started from here. The total revenue from X unit of jogging shoes and Y units of cross-trainer is given by which is in the next page. R is a function of xy is equal to minus 5x square minus 8y square minus 3xy plus 12x plus 102y, where x and y are in thousand of units. Find the value of x and y to maximize the total revenue. Here R is revenue. We have to maximize the total revenue. Revenue R is maximized, means we have to find the value of x and y for which R is maximum. For maxima and minima, we know that first of all we discuss about x and y. The total revenue from x unit of jogging shoe, the number of jogging shoes is x unit, which is given in thousand. In next page we read and number of cross trainers unit is y thousand, which is given. Y unit means y thousand, which is given in here. Next page. So only we have to maximize R, and for this value of x and y find out. We are given that the value of x, which is given in minus 5x square minus 8y square minus 2xy plus 42x plus 102y. We differentiate. We write in next steps only R, which is function of xy, which is already given here. So I differentiate R with respect to x because we have to maximize R, maximize or minimize, and maximize for and find the value of x for R is maxima. For this we have to find first derivative with respect to x and y, and also find the second derivative of R with respect to x and y. Then we go to apply Lagrange's condition through which we can say R is maxima or minima for particular value. So first of all find the value of del R over del x. So differentiate this value with respect to x. For in partial differentiation y is constant with respect to x. So differentiate this 5 is constant, differentiation of x square is 2x, and differentiation of this value is 0. Differentiation of this value we can take out 2y as constant, and differentiation of x is 1, and differentiation of this value is 41 into 1, and differentiation of this with respect to x is 0. Now in next step we write in simple form 10 minus 10x minus 2y plus 42. This is value of del R over del x. Also we have to find the value of del R over del y. So differentiate this value with respect to y partially. In partial differentiation x is constant with respect to y, so this differentiation is 0. Only differentiate next term 8 into 2y, and differentiation this value we get 2x into 1, and differentiation of this value is 0. Differentiation of this is 102 into 1. So value of del R over del y, it becomes minus 16y minus 2x plus 102. Now for maxima minima, we have to find also value of del 2r over del x square. For convenience, we write this value as small r, and this also written small r for function second derivative with respect to x in general meaning. This value can be find as a differentiation of del r over del x with respect to del over del x. We have find the value of del r over del x, which is written here. You are seeing that this value, you can use this value. Del over del x, and write the value over del r, which is minus 10x minus 2y plus 42. We differentiate with respect to x, we get minus 10 into 1, and differentiation of 2y is 0, and also differentiation of constant is 0. Only we get minus 10, which is value of del 2r over del y square. We can write it as r, and this will maxima for all value of x and y if first condition is satisfied, which is rt minus s square. R is here, and we define in next step as. We know that s is del 2r over del x del y. We can find this value as a differentiation of del r over del y with respect to del over del x. We can find the s. This value in short we write s, small s. So for this find this value, we put this value which we have find in this step. So I write this value and find the second derivative with respect to x and y, which I write here as. You can also write as. So I put the value of del r over del y and get minus 16y minus 2x plus 102. On differentiate this value, we get a differentiation of this value is 0, and differentiation of this value minus 3 into 1, and differentiation of this is 0. Therefore s is equal to minus 2. This value on differentiation becomes minus 2. And now we have to find the value of r. R is equal to which is function, any function which are given, and differentiate this value with respect to y partially 2 times, and this value can obtain by differentiating del r over del y with respect to del over del y. This value I write here which we can use. So del over del y minus 16y minus 2x plus 102. On differentiating this value with respect to t, we get minus 16 into 1 minus 0 plus 0. T is all these values constant. So we can say about maxima and minima without finding the value of x and y. But we have to find the value of x, y. We can check rt minus s square and sign of r, and say this function r is maxima or minima. But for maxima and minima, but we have to find the value of x and y also. So I can find this value for maxima and minima as for maximum or minimum value of r, capital R. We know that del r over del x is equal to 0, and also del r over del y is equal to 0. This value we have find in earlier steps which are this value and this value. So I put this value which is equal to minus 10x minus 2y plus 42 is equal to 0, and this value is 16y minus 2x plus 102 is equal to 0. We have to solve this equation, and I write this equation as equation number 1 and this as equation number 2. If you find the value of x, you have to, if you want to find the value of x, you should eliminate y in both equation. For this you have to make coefficient of y equal. For this you should find the LCM of coefficient of y in both. 2 and 16, LCM is 16, so you make in both coefficient of y is 16, but here is 16. There is no need to make here 16, only we have to work here and make this coefficient become become 16. So multiply this equation by 8 and subtract equation 2 here, and equation 1 multiplied by 8 and subtract equation 2, we get we can eliminate y. Multiply 8, we get minus 80x and minus 60y and plus on multiply here 8, we get 336 is equal to 0. Equation 1 now becomes equation 3, and equation 2 write as and coefficient and term of like term write on beneath the like term. Means my mean is minus 2x should be right on below in 18x, so write minus 2x here, and 16 between beneath 16y, and write constant 102 is equal to 0. It is equation number 2. I subtract this equation 2 from 3. So we change sign of second equation, then this sign becomes plus and this minus. This value is plus, this minus, so this will eliminate it y, and we get on subtraction result of because this value plus this value negative, difference of this value is 78, but this value is negative due to sign of greater quantity 78x. And also this sign is plus, because this plus greater value is plus and lower value is minus, and subtract 6 minus 2 is equal to 4, and 3 minus 0 is equal to 3, and 3 minus 1 equal to 2. And on transposing this this term to right, we get minus 78. Minus 78x is equal to minus we have to see 234, minus 234. Minus is cancel out from both sides. We can find the value of x by dividing 234 by 78, and on calculating, on dividing by 13 we get 13. We calculate here. On dividing 234 by 13, we get 18, so we get here 18, and on dividing we 13 6 is 78, and on again dividing by 6 we get 3. Value of x is 3, and put this value in equation 1 or 2, we will get the value of x and y. So we put the value of x in equation number 1, putting this value in equation number 3. we get minus 10x is equal to 3. Minus 10x, x value is 3, minus 2y plus 42. Minus 2y plus 42 is equal to 0. The value of x is equal to 3, and in equation number 1, this is equation number 1. I put this value in equation number 1, and we will find the value of y. On multiplying, we get minus 30 minus 2y plus 42 is equal to 0. Difference of these two value is 12 is equal to 0. And now transposing 12 on right hand side, we get minus 12 and cancel out to minus, and 12y divided by 2, we get 6. Value of y is 6. We have to now find at this value of x and y the sign of x and y. At x is equal to 3, y is equal to 6, which are in thousands unit. The value of r, since value of r, s and t are constant, so there is no change. If it is equal to 10xy, so we have to put the value of x and y, but it is here is a constant, so there is no change on putting the value of x and y, so it remain r is equal to minus 10. And this argument also for s and t. What in general case, you find the value of x and y, and then put the and at this point find the value of r, s and t on this point. If r, s, t are function of x, y, but here is r, s, t is not function of x, y only. This is constant value. As previous I say that we can also find the nature of r, which is maxima or minima without the value of x and y. What we have to find the value of x, y, so I find first value of x, y, and then we discuss the nature of maxima minima at this point. At this point we have find the nature of maxima minima, nature of function which are maxima or minima. First we check by Lagrange's identity, or Lagrange's identity, RT minus s square. You write in question, it is a discriminant. So put the value of r, which is minus 10, and value of t, which is minus 16, minus value of s is minus 2, and here s square, so I write minus 2 whole square. On multiplying this value, we get minus multiplication is plus, so 160, minus square of minus is plus, so square of 2 is plus 4, and difference is means value of RT minus S square is 156. In your you provide me question with article in which r is del 2 r over del x square and del 2 r over del y square, minus value of s is del 2 r over del x by del y whole of square, which is equal to 156, which is greater than 0. So the function is either maxima or minima. But how we can say that r is maxima minima? For this value, sign of r will tell about nature of function r. We are given we have find the value of r is minus 10, which is negative, so our function is maxima. Therefore r is, by Lagrange's identity, r is maxima. But this value is on the point maxima, but this value on the point x is equal to 3 and y is equal to 6 in 1000 unit. We have to find only value of x by for r is maxima. Here we have proved r is maxima by last two values of this value. For this value tell us about function r is either maxima or minima. Value of r confirm that our function capital R is maxima. R is also function of x y, and this value is at the point is x equal to 3 and y is equal to 6, which is given in 1000. Thank you very much indeed for listening me. Wa akhiru dawana alhamdulillahi rabbil alamin.